Welcome to 8.5, Determining Which Method to Use. In this section, we look at a mixture of problems and we talk about how to recognize from the wording of a problem whether we're in 8.1 or 8.2 or 8.3, and then that tells us how to proceed. So as it says, there is actually no material in this section. Instead, we have a mix of problems, and it does say from 8.1 to 8.4, but really that should just be 8.3. And our first task on each problem is to sort out what information is given so we know how to proceed. I mentioned 8.4, but since we didn't cover that section, there are no assigned problems from it, and it will not be on the exam. 8.4 covered finding a confidence interval for sigma, the population standard deviation, starting from a sample standard deviation S. It's definitely more complicated than what we learned in 8.1 to 8.3, but have a look if you like. Let's work through the check your understanding problems on page 408. So number one, a simple random sample of size 15, so that's already my sample size, N, has a mean sample, mean x bar equals 10.34, and a sample standard deviation S equals 3.48. The population is normally distributed. That's always good to have. Construct a 95% confidence interval for the population standard deviation. So right there, the first check your understanding problem is about standard deviation. That's 8.4. We're going to skip this problem. And you will certainly not see any of these kinds of problems in your homework or on the exam. But I thought I'd throw it in there just to give us practice reading the problem. So now we'll go on to the next one, number two, a simple random sample of size 80. So there's our sample size, has a mean x bar, that's talking about the sample, so it uses the sample notation. X bar equals 7.31. The population standard deviation is sigma equals 6.26. Construct a 99% confidence interval for the population mean. So right there, we're asked about mean. So already I know we're in 8.1 or 8.2. You might have that little chart out next to you or your index card. And it's a population mean, and so it's means. And sigma is given to us, sigma known. So if you think in terms of sections, that's section 8.1. We're going to use the normal distribution in particular. And if you want to go through calculating the z-scores and then doing the margin of error and then getting the confidence interval, you're welcome to do so. I am going to go straight to the calculator and I'm going to use z-interval. And it's super important to use z-interval because that's for the normal distribution. So go ahead and call that up on your calculator, plug in all the information. Again, we've got x bar equals 7.31, sigma equals 6.26, and our sample size is 80. I'm plugging all that in with our confidence level of 99%. I'm going to continue writing decimals, though we did discover that it can be a whole number, interestingly. And remember, that's in the stat button tests area. All right, and I get my interval of 5.5072 and 9.1128. And since there's no context to this problem, I'm not going to worry about the interpretation part. Okay, next example, number 3 of the Check Your Understandings. In a simple random sample of 100 children, so there's our sample size, 22 had reading skills above their grade level. Construct a 99% confidence interval for the proportion of children who have reading skills above their grade level. So we see the word proportion, so that's huge. And then notice that this is 22 out of 100. It's very different information than giving us a sample mean kind of a thing. When they give us 22 out of 100, that's giving us our X number and our N number. So p hat, if you want to find that, would be x over n, or 22 out of 100.22. We don't need that for the calculator, but just throwing that in. And then recognizing that it is proportions, that's our 8.3 section. For the interval, we can go right to 1 prop z interval, z int, and plug in the information. Just to remind you, I didn't on the last problem, but we're not dealing directly with data, so make sure you're in the stat option. That might have come up on the last problem also. Okay, plugging all that in, I get the interval 0.1133 up to 0.3267. And since this does have an interpretation, we're talking about children reading above their grade level, I am going to interpret this. And again, on the exam, I do ask you to interpret whenever there's meaning. So we are 99% confident. Always start your interpretations that way. We are 99% confident that the proportion of children who have reading skills above their grade level, it takes a while to write that out, so I'm going to pause and write that out. So you can see I've paraphrased just a little bit, but I said, reading again, we are 99% confident that the proportion of all children who read above their grade level is between 0.113 and 0.327. So I rounded a little bit, and if you're more comfortable with percents, I don't mind if you change these numbers to percents. So that would be 11.3% and 32.7%. That can be your choice. All right, let's do the next one, number 4. A simple random sample of size 25. So there's our n. We're back to a sample mean of 17.4, and then standard deviation. First of all, notice there's an S, and then notice this first sentence is all one sentence about the sample. So we're talking about the sample size, the sample mean, and the sample standard deviation. Compare that to number 2. You might go back and look at that. All right, and the population is approximately normally distributed. That's good, since our sample size is small. Okay, and then we're constructing a 95% confidence interval for the mean. So it's means sigma unknown. That's 8.2, and that's going to be the t-distribution. So we're going to use t-interval for this problem. Okay. Right. Again, recognizing the distribution as the t-distribution tells us to use the t-interval. That's super, super important. So plugging that all in and writing down what we get, I got 15.212 up to 19.588. And again, since there's no interpretation, there's no context for this problem, I won't bother with an interpretation. Okay, so we're going to wrap up this section with a reminder that sometimes we work directly with a data set. So I'm going to use the setup in number 18 from our text, but I'm going to modify the question. It's a standard deviation question, but we can use the same data for a mean question. So following are the numbers of grams of sugar per 100 grams of apple in a random sample of 6. Look at that, it's given to us in a word this time, but we've got a sample size of 6 numbers, red delicious apples. So these are grams of sugar per 100 grams of apple in this sample size. So we want to construct a 95% confidence interval, and I'm going to modify that to say the mean number of grams per sugar. So we don't have a sample mean, right? But we don't need it. We don't even have to calculate it. We're going to put the data into L1. All right, so then remember that stat edit. Haven't done that too much in this chapter, but stat edit. And then because we have a mean but no sigma, no standard deviation given, so we're going to use t-interval, and we're going to choose the data option. And then we want to make sure that we tell the calculator to use L1. So once you're in t-interval with that data option, you'll see list, and that's where you want to make sure it says L1. And then for frequency, because we didn't set up a frequency list, you just want to leave the number 1 there. And then your confidence level, 95%, so 95 or 0.95. And then go ahead and calculate, and I get 11.195 up to 13.405. And now this is talking about sugar content in apples, so I am going to interpret this. So, remember how we start. Shout it out. Yeah, did you say we are 95% confident that? And then use your own wording. I'll write something down, but yours might be a little different. As long as you get the gist of it, it'll be okay. How'd you do? This is what I came up with. We are 95% confident that the mean sugar content for all Red Delicious apples is between, rounded, 11.2 grams and 13.4 grams per 100 grams of apple. All right, that's it for this section. Be sure to review finding a minimum sample size in 8.1 and 8.3 also. And then some of the vocabulary. Remember we had point estimate, to review, maybe margin of error. I could ask problems for each of those little pieces, z-scores, critical values. Those are all the little bits and pieces that are in each section, but this is a big overview for the actual interviews and intervals. Okay, we're done.